So we talked about some. Excuse, I want to know, somebody was removed from the meeting. Is there any problem? The one who are co-hosts, just check on that. Okay. So when we talk about income, we talk about income, demand, and this is called as income elasticity of demand. Okay. Then the third one is when we talk about price of related goods. And if you remember over here, we had talked about two types of goods. That was substitute goods and complementary goods. So when I talk about these two, then it is called as cross elasticity of demand. So there are three types of elasticities depending on three different determinants of demand. So I hope this is clear to everyone, because this is just the beginning. Now we will start and we will discuss in details the first one, that is the price elasticity of demand. Okay, so we say, what is price elasticity of demand? It is the responsiveness of demand to a change in price. So because of a change in price, by how much is demand changing is studied under price elasticity of demand. So if you see, the formula for this we write is EP, you can also write it as ED, is equal to percentage change in quantity demanded upon percentage change in price. Okay, so generally this formula is a very important formula, and it talks about how a particular product is going to be influenced by a change in price. Okay, so if you see over here, now according to this and according to different kinds of goods, we have different degrees of elasticity of demand. So we come to the degrees of elasticity of demand. Okay, so the first one that you have is called as a perfectly elastic demand. Okay, so what is a perfectly elastic demand? We'll say that, suppose I'll draw the curve first and then I'll explain it. So here we say this is your price and this is your quantity demand. So P is the price over here. Now, what happens is, if the price changes by such a small amount that you can even put a separate line, okay, that much small change will bring about a huge change in quantity demanded. So suppose your quantity was here, a very, very small change means maybe $0.2 or even lesser than that. If there's such a small change which can't be even shown, we say there is a huge change in quantity demanded. So I'm saying there is a 10% change in elasticity. How do we write it? Elasticity of demand is equal to 10% divided by 0%. So this will be equal to infinity. Anything divided by 0 is infinity. So in this case, elasticity of demand is equal to infinity. This kind of curve is the demand curve which you find in a perfectly, in the case of, in the case of perfect competition. Okay. We will study this also in details in maybe in the next classes. So this basically tells you that how is it changing. Now let me give you an example so that you all can understand better. So suppose I say, if you see fish market, Okay, so fish market, not if you go to a normal fish market. Suppose people are just fishing near the sea, and they are just sitting there and selling things. Like in India, Bombay, Vishakhapatnam, these are huge areas where a lot of fishing is done. Now you'll find all these fisherwomen, they will be sitting all next to each other and selling fish. Now they've caught the fish from the same sea, so naturally you can't say that there's a difference. So generally, we might say there are little differences in sizes or something, but normally the fish is similar. Okay, so what happens here is, if one person drops the price by very small amount, everybody will run to him and just buy that fish off. Okay, if anybody raises the price, nobody will go to him. Everybody will want to buy at that one price which is there in the market. So that is a very important thing about a perfectly elastic market. So here, you can also take the market for onions. Okay, so in the market for onions also, you'll see the prices don't actually matter that much. They will generally be, everybody in the market generally sells at the same price. So this is a competition where we say that generally everybody has the same kind of things, and they will want to sell it at the same kind of prices. So not much prices difference will be there, not what a much product difference will be there. So if one person sells it even for a very less difference, everybody will go to the person and buy the commodity. So this is the first kind of elasticity. I hope this is clear to everyone. Is this clear to everyone? Is this clear to everyone?
Yes, ma'am.
Okay. Now we come to the second one. The second one is the other extreme. So the second one that we talk about is called as perfectly inelastic market. Perfectly inelastic market. Now, what happens in a perfectly inelastic market is, again, we draw the curve over here, but the interesting part is your demand curve looks like a curve like this and this. Okay, so what do you find? Here you have taken price, here you have taken quantity demanded. Now, in this case, what will you find is that, suppose we say that the price increases. So the price is OP, and the price increases to OP dash. Okay, so there is a 20% increase in price, but we'll feel, or we find, there is no change in quantity. The quantity will remain the same. So in this case, we will say elasticity of demand is, as you know, percentage change in quantity upon percentage change in price. So you'll have 0% upon 20%. So that is equal to 0. So here we say elasticity of demand is equal to 0. Okay. Now, what is the example of this? You can say the best example that you take is essential medicines. So, what do you find in case of essential medicines? You will find that if you're sick, and you go to a doctor, and the doctor tells you that you have to have maybe a particular medicine for 3 days, or you have to have a course of antibiotics for 5 days. Now, he has asked you to have a particular medicine. uh, Whatever the price, we will go and buy it in the market. So if the person says no, the rates have gone up and this has become more expensive, does it happen that we'll say no, no, we don't want to buy this medicine because it is expensive? No. If we are not well, we will have the medicine in the dose which is required for us. On the other hand, suppose the chemist says, oh, there's an offer, you are getting 10% off on medicines. Will we sit down and eat more medicines? Do you think that if there's a discount, you will eat more medicines for fever or cough and cold or whatever? Yes or no? Please tell me. Yeah. Can I have some answers written in the chat box only, please? Even if it is 10 or 12 of you, I'd like to hear a response. So, do we buy more medicine if there is a discount? Is my question. Yes? Anybody? Can I have some response? Then I'll know at least, you all are listening to it. Okay. So, yeah, Mustafa, you have written no. Correct. So that means that in this kind of market, we are not going to be impacted by change in price. If we have to buy one medicine, then we will only buy that much. For example, during COVID, everybody was running for oxygen cylinders. Now, nobody bought 20 cylinders. If there was requirement, then only a person went and bought, and they were charging very high prices, at least in India, for this oxygen cylinders because it was so high in demand. But if a person's life was at stake, you will buy it whatever is the price. So it doesn't matter what is the price, the amount which you need to buy, you will have to buy that much. So this is called as a perfectly elastic market. Okay. Now, the third one that we talk about is called as a relatively elastic market. So, when we talk about relatively elastic market, we will say that you have a demand curve which is flat. Okay, what does this mean? Let me draw the diagram first, then I will explain. Okay. Yeah. So suppose I talk about the demand curve over here and I say that, sorry, I'm not very happy. One second, I'll redraw this because I'm not happy with this diagram. Yeah, one second. I'll just draw it properly for you all to understand better. So it's sometimes difficult to draw on this, so that's the reason. Okay. So, okay, I think that's better. Okay, so now here I have taken price and I'm taking quantity demanded, and this is my demand curve. Now, in this case, what do we find? That if the price was OP, then you were buying lesser quantity. But the moment the price came down to P dash, the quantity increased very much. So, if the price decreased by 10%, the quantity increased by 50%. So, in this case, elasticity of demand will be equal to 50 upon 10%. That is equal to 5%. Or we can write elasticity of demand is greater than 1. Okay. So, this is a very, very common area where we talk about comfort goods, luxury goods, clothes, all this will come under this area. So, what do you find over here is, suppose like there's a discount. Yesterday, I think we were discussing about different kind of sales which happens in electronics and other things, at least in India. So, suppose you say that. The price of television sets is has decreased, or there's an offer on television sets for some time where the price has gone down by 30%. Naturally, many people will want to buy it at that time. Okay, so earlier maybe the price was maybe $10,000. Okay, and now the price has become $5,000. Naturally, the number of people running to buy this television set, you say it's an Apple TV and you're getting it for 5,000 bucks, you will want to probably go. And suppose it comes down more to 1,000 bucks, so naturally, many people will want to go and buy it. So here we say that there's a huge demand, huge change in demand due to a change in price. So a small demand drop in demand, that means 10% you have talked about the price going down, but because of that 10% prices going down, you find that the demand has increased to a very large extent. So that is something which is very, very important. Okay. Now, after this, we come to the next one, that is the fourth one. The fourth one is called as relatively inelastic demand. So when we talk about relatively inelastic demand, in this case, we will say that the demand curve is a very steep curve. What does a steep curve show? It shows that suppose the price is OP, I'll just come to it, and okay. So in this case, what do you find? That if initially your price was OP, you were buying OQ quantity. If the price decreases by some 50% also, there is only a 10% increase in quantity. So here you are saying elasticity of demand is 10% divided by 50%. So this is equal to 1 by 5. So elasticity of demand is less than 1. So in this case, the elasticity of demand is considered as less than 1. Now, what is the example for this? We say essential commodities. For example, if you eat rice on a daily basis, even if the price goes down, we don't start eating more rice, because we don't start eating 2 kgs of rice because the price of rice has decreased by 50%. If we eat whatever amount we eat, we will want to eat only that much. We will not change the amount that we are eating. Okay, so many of the things that we buy in our house are constant in nature. The amount of oil that you require for cooking, or the amount of rice that you require, the amount of maybe generally, if you talk about food articles, you'll find that you are talking about relatively inelastic demand, because maybe if something becomes cheaper, you might buy a little bit more. For example, if there is a decrease in prices tomatoes, you might say, okay, let me make some tomato sauce at home. But that does not mean that I can buy some 100 kgs of tomatoes. I can only, maybe if I'm buying 1 kg, I might buy 2 kgs, but not so much difference. So you'll find that in case of these kind of commodities, the price is not going to decrease to a very large extent. Okay, so these are 4. And the last kind of elasticity of demand is called as unit elastic demand. And in unit elastic demand, let me draw the diagram first. So here we say that an equal change in price and equal change in quantity. Okay, so if the price is OP and the quantity was OQ, if there is a 10% decrease in price, there's exactly a 10% increase in quantity. So here you say elasticity of demand is 10 upon 10, that is equal to 1. So elasticity of demand will be equal to 1. Okay, generally this curve is not found, and it is said that this angle over here is of 45 degrees angle. So the curve is at 45 degrees angle. That means there is exactly a proportionate change in price and quantity. Exactly what you are getting in terms of price is what you are going to change. Okay, so this is a very, very interesting case again, but I can't give you an example of this because you normally don't find this kind of curve in actual real life. So is this much clear to everybody, the degrees of price elasticity of demand? Is everybody clear on this? Is everybody, why am I not getting any response from class today? Yeah, okay. Yeah, thank you, Farida. So, okay. So this is, can I get some thumbs up or something from all of you so that I know you all are listening at least? Okay. Yeah, thank you, Grace. Yes, thank you, Farida. Yeah, Suleiman. Okay. Okay. So this is what we have to talk about. Yeah. Thank you, all of you. Okay. So this is what we talk about as elasticity of demand. Now, after this, we come to the problem of measurement of elasticity of demand. So when we talk about measurement of elasticity of demand, there are different methods which we will be using. And the first method is the method which we just dealt with. And that method is called as percentage method. So what is percentage method? It is what we have written earlier. So it is percentage change in quantity demanded upon percentage change in price. If you want to write it in a better manner, you will write it as delta Q upon delta P multiplied by P upon Q. So here delta Q is taken as change in quantity. Delta P is taken as change in price. P is your original price and Q is your original quantity. Okay, so this is the first method that we use for estimating price. Now let's just do a random question so that we say, so if we say that if for price rupees 10, quantity demanded was 10 units. Okay, if price increases to rupees 20, quantity demanded decreases to 5 units. Okay, so this is the question. Now what do we find? What is change in quantity? If you see, the change in quantity over here will be uh, you can take it as 5 minus 10, that is new quantity minus old quantity. So this amount you're getting as minus 5. What is the change in price? You will find the change in prices that it was 20 now and 10 earlier. So here you're taking this as 10. What is the original price? Original price was equal to rupees 10. What was the original quantity? It was equal to 10. So if you calculate it, you will get elasticity of demand is equal to minus 5 upon 10 multiplied by 10 upon 10. So you can cancel out and you'll get 1 by 2. So here you get minus 1 by 2. Now we will not consider this negative sign because the negative sign shows the relationship between price and quantity demanded. So if you remember, what is the shape of the curve? It is downward sloping. That means when the price is going down, then only the quantity is increasing. So one thing is decreasing, then only the other thing is increasing. That's why we will say that it is an inverse relationship. So this negative sign shows us the inverse relationship. So any calculation that you do about elasticity of demand will always be a negative curve. So in this case, we will say elasticity of demand is less than 1. So we will say it is relatively inelastic demand. Okay, so this is how you calculate elasticity through the first method. I'm just showing it to you. Any other questions? If you have any questions on this method, you can ask me. This is the first method of calculating elasticity of demand. Are there any questions on this? So you might just get a simple question like this telling you that initially your price is this 10 rupees and then your quantity is 10 units. And if the price is increasing or decreasing, what is the change in quantity? Okay, so like this, you will need to calculate. Remember that whenever you calculate the price will always be, one of them will be negative. Either the change in price will be negative or the change in demand will be negative. The reason behind this is that that there's an inverse relationship between price and quantity demanded. That's the reason that you will always have a negative curve. Okay. Is everybody clear with this method? The first method? Is everybody clear with this method?
Yes, ma'am.
Okay. So we come to the second method. The second method is called as the point method. Now, in the first method, or till now, we were saying that elasticity of demand on a particular curve is the same. That means throughout the curve, the elasticity of demand remains the same. Now, we come to a very new or a different concept, and that will be, okay, so this is your demand curve. Now, in this case, what do? We divide the demand curve into different portions. Okay. So we have divided the demand curve into 5 points. So this is B, C, D, and E. So here you have price and here you have quantity demanded. Now we are saying that at every point of the curve, the elasticity of demand is different. Okay. How do we calculate it? In this case, the formula that we use is elasticity of demand is equal to lower segment upon upper segment. Lower segment upon upper segment. So now we will try to calculate the elasticity at each point. So if we come to the first one at point A. Okay. So one second. Just the normal color. This is like. So we come to at point A. So what will happen at point A? So we have elasticity of demand is equal to 1, 2, 3, 4. There are 4 segments which are in the lower half, but above A there is nothing. So we will write 4 upon 0. So this is equal to infinity. So at point A, what is your elasticity of demand is equal to infinity, and we say there is perfectly elastic demand. Okay, so at point A, we said you have perfectly elastic demand. Now we come to at point B. What do you find? At point B, elasticity of demand is lower. There are 1, 2, 3 segments. Okay, and upside there is only this one segment. So it will be 3 by 1. So in this case, elasticity of demand will be greater than 1. So here you will have elasticity of demand is greater than 1. So you can say this is relatively elastic demand. Okay, so the second point that you get is relatively elastic demand. Now let's come to point C. So point C will be at point C. What do you find? You find elasticity of demand is equal to, there is 1 and 2 portions below, and there is 1 and 2 portions on top. So 2 by 2, that is equal to 1. So elasticity of demand is equal to 1. So here you will write elasticity of demand is equal to 1, and you will call this as unit elastic demand. Okay. Then we come to the next point where we say, sorry. Okay. Next point where we talk about at point D. So at point D, what do we find? Elasticity of demand is equal to, there are only one segment below, and there are 1, 2, 3 segments on top. So here you will say elasticity of demand is less than 1. So at point D, elasticity of demand is less than 1, and we call it as relatively inelastic demand. Okay, so in this case, we call it as relatively inelastic demand. And the last point you take is at, let me take another color. Okay, so last is at point E. You will say elasticity of demand is there is 0, nothing here. So 0 upon 1, 2, 3, 4. So in this case, elasticity of demand is equal to 0. So last point is elasticity of demand is equal to 0. So we call this as perfectly inelastic demand. Is it clear? So like this is another method. Now in this method, they have said that elasticity at different points of the curve will be different. Yes, good evening, Vasant. Uh, joined in a little late. We finished quite a bit. Okay. So here, if you see, there are different points that we are talking about. So at point A, we have relatively elastic demand. At point B, we have relatively elastic demand. At point C, you have unit elastic demand. At point D, you have relatively elastic demand. And at point E, you have perfectly elastic demand. So the elasticity of demand at different points of the curve is very, very different. Okay. So I hope this is clear to all of you. These are two important methods which are estimated for calculating your elasticity of demand. Okay. Second, I just wanted to check what else is there, which I can cover. Yes. Okay, so I think these are the two important methods they have also mentioned. So point method I have discussed with you. Arc, okay, arc method also I will talk about. Now there's another method, the third method, which is called as arc method. What does the arc method say? It is another different approach where we say that suppose this is your in this case I will just draw that. Suppose they say demand is a curve, it's not a straight line. So they say that suppose you're taking 2 points on the curve, one is A to B. Here you have price and here you have quantity demanded. So if you go from A to B point or B to A point, your elasticity should remain the same. Okay. So how do we calculate it? You say elasticity demand is Q1 minus Q0 divided by Q1 plus Q0 whole divided by P1 minus P0 upon P1 plus P0. So this is the formula that is used to calculate elasticity of demand. So here what is Q1? Q1 is new quantity. Q0 is old quantity. P1 is new price and P0 is old price. Okay, so this is in this case when you calculate, see if you calculate through percentage method, you'll find that if you're taking A as original quantity and B as new quantity, the answer will come out to be different. Okay, than if you take B as new quantity, original quantity, and A as new quantity. Means if you're taking that you have shifted from this A point to B point, you will get different elasticity, and if you move from B to A point, you'll get different elasticity. But if you use ARC method, means if you use this formula, you will get the same answer in both the cases. So this concept was given by Bumol, who was a very famous economist. And if you study sales maximization model also, you will find his name. So he's a very well-known economist, and he has talked about the concept of arc. That means between 2 points of a demand curve, the elasticity will be the same. Okay, so I hope everybody is clear with the methods of elasticity of demand. We dealt with three methods. The first method was where we talked about percentage change in price upon percentage change in quantity demanded. The second method we talked about was called as the point method, where we said that on different points of the curve, the elasticity is different. And the third method is called as arc method. That means between 2 points of the curve, the elasticity remains the same. Okay. Any questions still here? Is everybody clear till this point? Is everybody clear? I'm just showing this again, these two methods that we dealt with. So I hope everybody is clear till this particular point.
Clear, ma'am.
Clear? Okay. Anybody has any questions can ask me. That's why I'm pausing, that if you want to understand something once more, I can repeat it for you. Okay. Yeah. Okay. Fine. So next we come to the concept of actually the same thing, but you talk about it in terms of total revenue and average revenue curves. So when we talk about elasticity of demand, so I'll write this: elasticity of demand in terms of average revenue and total revenue curves. Okay. So what do we see is, I will draw these two curves one under the other. So 1 second. Okay. So okay, this is your total revenue curve, and from here you draw a connection, which is your highest point, and on the other one you draw your average revenue curve and your marginal revenue curve. We will deal with these two curves later also. So here we just want to study the elasticity concept. So in this case, you have price on this axis, and here you have total revenue, or you have quantity over here, and you have quantity here. So price, or you can also take over here, we are studying total revenue, and here we are studying average revenue and marginal revenue. So they say that the same point method is applied over here. So you find when total revenue is increasing, okay, when total revenue is increasing, at that point we will say, over here you can see this area. So we say that elasticity of demand will be greater than 1. So when total revenue is increasing, at that time the demand curve, average revenue is basically the demand curve of any firm. So you will find that elasticity of demand is greater than 1. Second point that you get over here is this point where total revenue is maximum. So if you see over here, you will say elasticity of demand is equal to 1. So this is the second stage, and you will say it is elastic. And if you, so here what was it? Elasticity of 1 is greater than 1 means this is a elastic demand. And this is the second one that you have is unit elastic. Okay, and when you find that total revenue starts going down, that means this portion of the curve, you will say elasticity of demand is less than 1. So you will say it is inelastic. Is this clear? So this is the relationship. When we study, this becomes very important, and like that with the revenue curve we can decide on how your total revenue and the elasticity in case of average revenue and total revenue can change. Okay. Okay, then after this we come to the next part, that is the determinants of price elasticity. Okay, so the next thing that we will talk about is determinants of price elasticity of demand. So what are the areas, or what are the things which decide about price elasticity of demand? The first determinant will be availability of substitutes. Availability of substitutes. Now, I would like to know from you all that if a good has many substitutes, what do you think will be the price elasticity? I want an answer from the class now. If a good has high number of many substitutes, what do you think is going to be the elasticity of the good? Please think and tell me. Suppose you say you talk about soft drinks market. Now, you like drinking Coke, but suddenly you go to a shop and he says Coke is very expensive today. You have to pay double the price. What will you do? Will you buy Coke or you will buy something else? Why is there so little response in class today? I normally like to talk in class, so I like to hear everybody. Yeah, so please tell me, any of you, that if the price of Coke goes up and you have other cold drinks and other things available, will you still keep drinking Coke or you will buy something else? Will buy something else. Okay, yes, Farida.
If we buy
Any-
something else, ma'am,
Yeah,
we'll
okay.
choose a
So
different soft drink.
yeah, so what kind of elasticity do you see over here? Can you guess?
Substitute, I think.
Yes. So, what will be the elasticity? Will it be elastic or will it be inelastic? Think and tell me. If you can decrease the demand of something when the price is going up, what kind of elasticity will the good have?
Could it be inelastic?
It will be elastic. That means because I have so many other options available to me, so naturally it will be elastic. But if you think of a good like salt, uh, you will say that it is inelastic. So there is no substitute for salt. No, you if in food you need little salt, so the elasticity for salt will always be inelastic. But if you talk about soft drinks, if you talk about clothes, if you talk about you know biscuits, you'll see that they'll all be elastic because you have got so many other options which are available to you. So if there are more substitutes, we say substitutes. Okay. Then we say it is highly elastic. Okay. The second example that you have is proportion of income spent. Okay. So when we talk about proportion of income spent, suppose you say for a packet of salt, you're just spending less than 1% of your income. Okay. So here, very little money is going. So you're not bothered if the price has become little bit more. Like in Indian rupees, I'll say that if the price was 10 rupees, now it has become 11 rupees. We are not going to bother about it at all because it's a very small portion of my income. So that's why we will say it is less elastic. But if you see, if I talk about a television set or I talk about a laptop, here the proportion of income which I'm spending is much larger. Means suppose it is costing, I'm earning maybe 50,000 rupees, and the cost of this laptop is only around 45,000 rupees. Okay, now naturally it will matter to me. Suppose there's an offer and this laptop now starts costing 25,000 rupees, I will definitely want to buy it. But when the price was here, I was thinking, okay, should I buy it? Should I not buy it? It's so much, such a huge amount. Can I actually afford to buy it? So what happens is, for these kind of things, where the proportion of income spent is more, it will be more elastic. Okay, because you are bothered that if the price changes, what is going to happen? I'll have to spend so much more money. But if it is 1 rupee 50 paisa, I will not bother about it. So if the amount of money which I have to spend is more, then naturally my inclination will be more elastic in nature, and I'll be more bothered about the prices which are happening in the place. Okay, so this is a second determinant of demand. Third very important determinant is time period. When are we buying the thing? So, suppose there's an exam today, you have come to write a paper and you have a maths paper. And for the maths paper, you need one calculator, and you forgot the calculator at home. Okay, and there's a small shop next to your exam center, and it is selling you the calculator at a much higher rate. Okay, will you go and buy it?
Yes, sir.
Yes, you will go and buy it because you have an exam. Now I can't do anything about it. I have to buy it because whatever he charges, I have to buy because my need is immediate. Now, suppose there's a shop outside your office or college, and you have an exam 1 month later. Will you still buy it at a high price?
No, since I have time, I can look for a cheaper one somewhere else.
Yes. So that's what we will do. Then okay, I have time, I'll see where I'll get it cheaper and go ahead and buy it. So if you have more time, you will say that the demand is going to be more elastic. So if you have more time to buy the product, then we will say that it is more elastic. And if we have less time, I need it immediately, okay, then we will say it is less elastic in nature. So these are some of the important things when we talk about elasticity of demand. So depending on this, we will see what we want to buy now, what we want to buy later. So if I'm spending a lot of money, I will think about it and see when the price is low. If I'm spending very small amount of my money, I will not bother. So here we have learned that elasticity for different goods is very very different. So it's important to now understand that what is the use of reading this concept. So ultimately, whenever we read a concept, it should lead us to something. So first thing we come to is importance of this concept is that you come to know about your budget. So you decide that how much money do I need to spend on what thing. Secondly, we say that foreign trade is very much based on this. For example, you have a country A which sells you um, things which are not clothes. Okay, so here we said the clothes have elastic demand. And there's a country B which sells you war goods. Okay, and this has inelastic demand, means you need to buy them. I told you yesterday that buying war goods is not about war, it is more about peace. To protect your borders, to stay safe, you need to buy war goods. It's not always that I want to fight with someone, so I buy war goods. I buy war goods because I want to protect my environment. So that is a very important concept. And being from India, I would say that we have never attacked another country, but we are very strong in our war goods because we don't. We will definitely protect ourselves. We do not want to go and take over somebody else's land or go and fight anywhere. So we have never attacked in our history, and it's a very old country. So in our history, India has never till date gone and attacked anybody. But yes, if somebody attacks me, if somebody enters my house and tries to take away my things, naturally I should have some protection. So for that, I will need to buy war goods. Now, I want to know, which country do you think is better off in terms of trade? So I said that clothes, if I'm saying I can do without cotton clothes, or I can just manage with other clothes. But can I manage without war goods? I can't manage without war goods. So I say that the terms of trade will be in the favor of this particular country. So similarly, if you see the case of oil, okay, the other countries might be producing spices, might be producing clothes, might be producing something else, but without oil we can't manage. So that's why the OPEC countries are always very strong in their trade terms. So you'll find that where you have an inelastic demand for the product, means we cannot do without it, that country always lies in a more beneficial area. And that's why this is a very big deciding factor when we talk about terms of trade. Okay, so I hope that was clear. The third point is also a very important thing when we talk about government policies. um, in any country, I don't know whether your country has it, and I would like to know, we have something which is called as the minimum support prices for farmers. So what we do is, we know that farm products are inelastic in nature. Like for example, uh, I said like onions, okay, or potatoes or any other vegetable. Do you go and buy 20 kgs of it because the price is low? No, because what will you do with it? Okay, if you are a family of two people or three people, you need less than 1 kg of a vegetable to survive. So you're not going to buy some 20 kgs because you can't keep it. Okay, so this kind of demand is inelastic. Now, if there is more production and there is a bumper crop and a lot of it is available in the market, uh, consumers are not going to buy more of it. So, what happens? The farmers incur a lot of loss. And because of that, the government fixes a certain rate. So, the government says, okay, you sell it through the market by whatever rate, but the minimum rate which is there is rupees 10. So I can sell it for 15 rupees, I can sell it for 25 rupees, I can sell it for 30 rupees, but below 10 rupees, the government will buy it. So it is a means to protect the farmers so that they do not have very much losses when there is overproduction of a particular crop, because you can't store it, consumers will not buy more of it. So where you have products which have an inelastic demand, for those kind of things, food items especially, the government has one of the policies which is called as minimum support pricing policy. So do you have something like this in your country, where the government supports the farmers by buying the produce if the price is going down below a certain limit?
Yes, we do in Zambia.
Okay, so what exactly is the policy?
Well, it starts from supporting them with fertilizers when it comes to the maize season until
Hmm.
they harvest. They find markets for the farmers. They also
Hmm.
even just subsidize uh, on, 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 on the efforts in terms of harvesting and things like that.
Okay, but does the
Finding
government
them
buy
ready.
it, buy the produce where below a certain price?
Yes, yes.
Okay, okay, okay. So then I think it is very similar to India, because I discussed with another group also of international students, and they said, many of them said, no, we don't have a policy. The government gives us support in terms of in terms of fertilizers and in terms of better quality seeds, but if there is more production at that time, the government does not tend to buy it. So there is a lot of wastage, and the farmers generally have a lot of problems because of that. So I think country wise the concept is quite different. So this is required because we are talking about inelastic demand. If it was elastic, no problem. If the price was less, people would have bought more and more quantities. But because it is inelastic, people cannot go and purchase more quantity, because food articles we can't do anything about. So that's why it is not something which farmers can also do anything about, or it's something that we also can't do anything about. So it is a difficult situation for farmers as such. Okay, so that completes your first area, which I said I will talk about, which is the elasticity of demand. So if there are any questions, I'll just give you 1 minute, and then I'll start with the next topic. So if there are any things, any questions or anything that you want to ask me, you can do that, and then I will start with the next portion, that is demand forecasting. Okay, and in that I will be doing one question about the regression methods which are used, so that you all can easily understand how to do the question. Okay, any questions on price elasticity? I hope it's clear to everyone. So that will complete your block 2 also today. And tomorrow's class, I will finish cost and revenue. And two more classes that I have, we will talk about market competition. So we will talk about perfect competition, lot of diagrams will be there, and we will talk about imperfect market competition. So that will complete the 6 classes which we have. So here we are nearly at the midpoint of, I think, your course. So tomorrow's class, I will talk about production and revenue. Those two topics I will be covering in tomorrow's class. Probably I'll be leaving you a little early tomorrow, so that we have something. So I will finish cost and revenue curves and production function in the next class. Okay. So now let me finish with demand forecasting today. So, demand forecasting that we talk about is a very, very important area of managerial economics. See, traditional economy does not talk about, it does not talk so much about the demand forecasting techniques. It is more that under managerial economics that you really need to know about demand forecasting techniques. And it's a very, very important technique, because at the end of the day, if you are producing more or you're producing less, both is a problem for the people. Okay, so if you're producing more, you don't have place to keep it, and if you're producing less, that means you could have sold more and you have a problem. So we just need to see how we can actually end up producing exactly the amount which is required in the market. So I don't produce more, I don't produce less. Okay, so that we take care through demand forecasting methods. Now, demand forecasting methods are divided into two different areas. One is your qualitative methods, and the second one will be your quantitative methods. So quantitative methods basically are more statistical techniques. So there are three different questions which are there, and I will solve those 1, 2 techniques with you all. Okay. So the first qualitative methods are basically, the qualitative methods are more where you're doing a survey and you're finding the opinion of different people. So the first one here is called as consumers opinion survey. So what is a consumer's opinion survey? Let me come to these methods first. So this is, here you have something which is called as a complete enumeration method. So I think the easier term which we use is called a census method. Means if there are 50 people who are buying your product, you will go and talk to all the 50 people and get everybody's opinion. So you do not miss out on any person. So if in a particular housing complex I have a shop, I will go to all the people who are there and take everybody's opinion and come. So that is taken as a complete enumeration method, where each and every customer's opinion is taken. But you can see that, suppose I'm a manufacturer and my biscuits are available all over my country. Now, if I have to go to every household or every consumer and I need to find out whether they are eating my biscuit and how many packets of biscuits they are buying and whether they like my biscuit, I will never be able to reach any kind of conclusion. So it will be a huge task and a very difficult task for me. So for that purpose, I will many times use a sample survey method. So what will I do is, maybe I can just have a stall in one of the shopping complex and put my products. Suppose I'll say that a new brand of coffee I want to launch. So I give my coffee to everybody. So everybody tastes my coffee and they say, oh, this is very nice, I would like to buy a packet. Or somebody says, no, I didn't like this at all, and I like the original taste only. So here you are finding the opinion of all the different people who have come to buy my coffee. And when you talk to these people, you will note down their numbers and come to know about their opinion, so you can talk to them. So that way what happens is, at the end of the day, you get a certain idea whether the product is liked by people or not liked by people. So you make a questionnaire and you ask them to answer. And this sample, like suppose you want to study about some maybe 500 odd people. So there are 5,000 people in a particular place. Now, out of this 5,000 people, I will take a sample of 50. So whatever the sample says, we will say, okay, now 50 people I talked to, and they all said they liked the biscuit. That means majority of the people, these 5,000 people, will also like the biscuit. So that is what we call as sample survey method. That according to few people or taking a smaller group, we are able to forecast for a general large group of people. Okay. The second is called as Salesforce composite method. Okay. So what is the Salesforce composite method? Under the Salesforce composite method, you will just talk to different salesmen, and you will find out, okay, you went to sell the thing. How did people like it? So many times the sales force, when they come to you, they can tell you better about how people liked it or didn't like it. Okay, so they can say, many people, many of the consumers were not even interested in looking at it. So when I'm trying to sell a certain commodity, I can make out better the response of different consumers for the product. Okay, it is very much possible that some of us are nice people. So if somebody feeds me a biscuit, I will not go and say, "Oh, I just don't like this taste." I'll say, "Oh, this was nice, but I'll come back and buy it next time." So if you are basing that on and making, different goods based on this, it is not such a good idea, because I have said that, oh yeah, it is nice, yeah, it is nice, but I know that I did not like the taste, and I will not go and buy that biscuit. But when the questionnaire has been filled and I have filled the questionnaire, I have given a positive thing. So they have added me as one customer, but I am not the customer, because I've just written something because I didn't want the other person to feel bad. But when the person is trying to sell me certain things, then the person knows exactly whether I'm buying the good or not. So you get a better opinion through the Salesforce composite method. The next method that we use, this is a very important method called as the Delphi technique. So what happens in the Delphi technique is, you have a number of people who you will consult. So about your organization, you will get the whole details about your organization, what kind of production capacity you have, what is your sales force, what is the costing which is there in your company, and how much are you marketing, how much are you spending on advertisement, what you're doing. So you make a complete report, and then you send it to certain experts. So these experts might tell you that yes, it is a good idea to increase production, or no, it's not a good idea to increase production, because the market is not good, so maybe the demand is not going to increase. So you get a input from these people, and according to that input, you will actually be able to tell what is happening and not happening. So that is called as a Delphi technique. Now suppose I have approached 4 or 5 experts. Okay, and they have all told me different things. So one person has said, yes, demand is increasing, increase your production. Another person is saying, no, no, market is very bad, please do not increase your production. A third person says, I think you're producing 100 units, that's good enough, you don't need to do anything. So now I've consulted 3 4 experts, and all of them have a different idea. So what do? I will call them for a particular meeting, and they will sit and discuss out why they have said a particular thing, and what is the basis of their observation, or their recommendation. And from that recommendation, what will I do is, I will ask them that please come together and discuss it together, and let us know what we should do. Because currently one person is saying don't produce, one person is saying produce, another person is saying just what you are doing is okay. So as a manager, I don't know, in spite of hiring 3 experts, I have not come to know what exactly I should be doing. So here you will find that this is a big mismatch. So these people come together, and when they come together, they will discuss, and they will be able to tell you that okay, the best thing that we can do is, they will discuss it out, and they'll say, I think the production should be increased only by 5%. So now all the experts have agreed on a point, and that is what will be carried on and used by the firm. So Delphi technique, since you know that we're talking about different consultants who are outside the firm, you can automatically make out that it is an expensive method. It is not something which everybody can keep doing. So it is an expensive method for any particular firm to use. Then we also have a technique which is called as test marketing. And test marketing is a very good marketing technique when we think that a new product, suppose I want to introduce avocado biscuits or mint biscuits into the market, or maybe even chili flavored biscuits into the market. So I just want something totally new. Now, if I start with mass production just immediately, I'll find that I might just go wrong, because if I just think that okay, tomorrow's date I will be sending my biscuits everywhere and I've produced a lot of biscuits, what is going to happen is you might not get the sales. So what do? Is you decide on 2-3 areas, you select 2-3 areas or 2-3 shopping areas, or where you find different kind of customers and very popular joints. So you just bring this biscuit out into those particular markets and see over a certain period of time, maybe 6 months. So over 6 months you just see whether people are coming back and again buying those biscuits or not. So first time maybe you gave them 2 free biscuits to eat and they said yes, we want to take 2 packets. They bought it and they went. Now, are those people coming back next time again, maybe next month when they're coming back? Are they looking for the biscuit? So you'll find that some product, if you've tasted and picked up, next time when you go to the market, you're like, oh, I really want that one more thing. Last time I picked it up, it was really good and I want some more of it. Okay, so that is how in test marketing we find out that this particular product has become very popular. So we can say that we can market it more and more. So I can bring about a lot of production because the market wants to buy this product. So test marketing is a very good way of finding out. Sometimes people will say, no, I think it's okay, but it's not worth the cost, or I don't like this flavor so much, or you get these kind of results. So you come to know, okay, this is not a good idea. And maybe I've launched 5 types of biscuits in the market, and I find that my chocolate flavor is very popular, and maybe my mint flavor is very popular, but nobody wants to buy those chili biscuits or the avocado biscuits. So what will I do now? I will decide that out of the 4 varieties of biscuits which I wanted to bring into the market, I am only going to run chocolate biscuits and mint biscuits. So I get the feedback and accordingly I can improve, and then I can go into mass scale production. So these are some of the important quantitative methods. There are many more. Actually, if you see the methods of demand forecasting, they're very, very huge. Now, it's not possible to actually cover so many methods over here. So next we come to quantitative methods. Under quantitative methods, I will deal with 2 kinds of sums. The first is called as the moving averages, and the second is regression analysis. And you can also say time series analysis. So this is the area which I will cover, and I'll try to do at least one question. Just give me a second. Let me see if I have the adequate. Yeah. And I will also do one more method, that is your graphical method. So I will try to cover at least one of these so that you get some kind of idea on the different kind of techniques. Now, the first method, as I said, is the graphical method. So in graphical method, what happens is, suppose you've got information of year and production. Okay. So when we take year, you are taking 2010, 2011, 2012, 2013, 2014, 2015. Okay, and you saw that production was over here 200 units, then it went to 180 units, then it went up to 250 units, then it became 350 units, then it became 400 units, now it is 500 units. So what you're doing is you will try to plot this. So you will take year here and you will take production here. So suppose for the year 2010, you said the production was, I'm just roughly drawing it just to give you an idea. So this is 300. Suppose you take 400 and 500. So in the first year, I see there's a production of 200 units. So second year, 2011, the production has gone down to 180. The third year, 2012, we find that the production has gone up to some 250 units. Then 2013, the production has gone out to some 350. 350. 2014, it has increased to 400, and 2015, it has become 500. So you can see it is going like this. Okay, so some kind of value like this. It can be up and down. I'm just drawing an approximation. So you can see what kind of trend is there. There is an upward trend. So we can say that, the demand for the product is increasing. So looking at this, we can say that yes, it makes sense that in 2016 this might increase further. So it is something which I'm predicting. So this part is my prediction that in 2016 probably the price of the product can be 550 units. So I'm just making a prediction based on the other areas or earlier what was happening. So that is called as a graphical method, and it's very popularly used. You can see in stock markets and all, people will say, oh, there's an upward trend, oh, there's a downward trend. So very frequently graphical method is used for forecasting different kinds of demand. So just looking at the diagram, you can say, oh, see how nice it is that there's an upward trend. So normally from here, very rarely you'll find that it will drop down like this. It doesn't happen. So unless something, for example, COVID has happened, so naturally demand has dropped like this. But otherwise, if you see there, if there's an upward trend which is showing, if there's an upward trend, you will see that the upward trend will continue. So according to this, my prediction now is that I should produce 550 units of that particular commodity. Is everybody clear till here? So this is the first method. I hope this is clear. All the qualitative methods and the first quantitative method. Is it clear to everyone?
Yes,
Yes,
ma'am.
it is clear.
Okay, yeah. So the next method that we talk about is called as moving averages method. Okay, so the second method is called as moving averages method. And in this, we have different kind of averages. So you will have 3-yearly moving average. You will have 4-yearly moving average. You will have 5-yearly moving average. Now, I want you all to solve this question with me and give me the answers for this. Otherwise, it makes no sense doing this question. So I'm just giving you some small values and I will tell you how to calculate, but the answer should come from you. You can write it in the chat, but I want you all to solve this. So here we have year and we have maybe sales. Okay. So you are taking the year 2015, 2016, 2017, 2018, 2019, 2020, 2021. Okay, so these are the years that I have taken for sales. Now I'm just taking very, very simple amounts just to make you understand the different concepts. So you've taken 5, 10, 15, 20, 25, 30, 35. Okay. It will not be like this. There will be change in values, but just to understand the concept, I'm taking this. So first we calculate 3-yearly average. Okay. What am I writing? 3-yearly average. I'll not be dealing with the 4 yearly average. I will deal with 3 yearly average, and I will deal with 5 yearly average. Okay. So when we talk about the 3 yearly average, I'll just try to make you understand. So we take 3 years. So it is 5 plus 10 plus 15. What is the amount that we get?
30.
30. So we do 30 divided by 3. That is equal to 10. So the first average we write, see, this is very important. See where I'm writing it. So you have to take a centered value and write the value of the average. So this is the first average. Now, if you take a general average, you will take it from 20, 25, 30. But because it's a moving average, what will I take? The next group, I will take 10 plus 15 plus 20. Okay. So what is the value? The value? Anybody?
Is it 45?
45. So it will be 45 divided by 3. That is how much?
15.
How much? 20,
15.
15. Okay. So what am I writing it against? 2017. So remember, there is no value that I've written with the first one. But slowly I am going one step down to calculate the average. So the next group now I take will be from where? It will be from 15 to 25. Okay, is it clear? Is everybody clear? That's why I'm using different colors, so you don't there's no problem understanding. Yeah. So what is the third one that you're getting? 15
60.
plus 20, 60 divided by 3. This will come out to be 20. Okay, I hope everybody is following me. Okay, then the next group that I will take will be from where? 20, 25 and 30. This is the next group. How much is this?
75.
75 divided by 3 will come out to be please tell me
25.
25. Okay, then next one that we have, next group will be 25, 30, 35. That is against this. How much is this one?
90.
90 divided by 3, that is 30. So is it clear? So the first and the last value, if you see, is a dash. We always write the centered value. So we don't write the value from the first value. We will always go one step down and write a centered value. That's why it is called as a moving average. The difference between a moving average and a normal average is, I'll just give an example. So suppose you've got 1, 2, 3, 4, 5, 6. If you're taking a normal average, you will take a group of this and calculate average. You will take a group of this and calculate average. This is how a normal average is calculated. But because it's a moving average, we go one step down and we keep finding out the average. How does it help? It tells us the trend. So if you plot this, you will get a trend, whether the values are going upwards or whether the values are going downwards. So you come to know about how the movement is taking place. So that's why it is a very important concept when we talk about demand forecasting. Now, when we are taking a 5 yearly average, we will do the same thing, that we'll take the first 5 values. So it is 2015, 2016, 2017, 2018, 2019. Now tell me, what is the value? Again, what do we take? We take the centered value. Now in this case, what is the centered value? This one, because we are taking 2015 to 19. So the centered value will be against 2017. So what is the sum total value? Please tell me for the first one.
75.
How much? it should be 5 plus 10 plus 15 plus 20 plus 25. $75. Yeah. So 75 divided by 5. So how much will it be? Mhm, 50. Okay. So you'll find that in this case, the first two we will write as a dash. Then we come to the second group. The second group will go from here till here. Now, please tell me the value for the second group. So you're taking from 2016 to 2020. This is second group. What is the value? Please add and tell me what is the value. Anyone? It will be 10 plus 15 plus 20 plus 25 plus 30.
$100?
Yes. Is it 100 or is it 90? 10 plus 50, 25, 30, 40, 50, 65, 70, 80, 90, I think. Just cross check 1 minute. I think it is 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 100. Correct. So it's 100 divided by 5. So what do you get? You get it as 20. Correct. The third value that we have is you will shift 1 down, and this is the last group. Okay. So in this group, you are taking from 2017 to 2021. So what is this value? Is it clear to everybody what we are doing? We're just taking 1 year down and taking it. But the important point is in this, the first two values and the last two values will be a dash. Please tell me this last value that you're getting.
125.
125 divided by 5.
125, ma'am.
Yeah. So this will come out to be 25. So this is how you calculate the 5-yearly and 4-yearly moving average. I hope it was clear to everybody.
It's
So
clear,
I will
ma'am.
come to the last. Yeah, it's clear. So it's just a very simple concept. Many times in economics, we find that the words sound very heavy, but if you understand, the concepts are very easy to understand. Once you understand, it's a very beautiful subject. It's only if we try to just learn it, there's a problem because you can't just learn the graphs. You have to understand them to actually know how the subject works. So that's a very important point of economics. Okay, and that's the beauty of economics. I think that's why it's interesting. Now we'll come to the last method, which is I'll just talk about this so that you understand. There are two methods which I've mentioned. One I have mentioned is time series analysis, and the second one I have mentioned is regression analysis. So just looking at the question, you can make out whether it is time series analysis or regression analysis. I'll just be doing one question over here because the methodology of doing the questions is the same. It's only that the information which is presented to you is different. For example, under time series analysis, one indicator will always be here. So if you look at the data and you find year and quantity demanded or anything like this, it is always time series analysis. Okay, and if you get that find how sales and demand are working. Okay, this here you've got two variables. There is no time element over here. So then this is a regression analysis. Rest of it, generally, the method of solving the question is the same. Only difference is there's always an element of time when we talk about time series analysis. So I'll be doing one question on time series analysis for you all. I'll just do it on the next page so that you know the whole thing is together. So for time series analysis, let me write down this question. So you've got year and demand. Okay, so year is taken as 2001. Let me just write the question down. 2002, 2003, 2004, 2005. So here we say n is equal to 5. That means I've taken data for 5 years. That's why n is taken as 5. Now demand is taken as y. Okay, demand is always written as y, and basically this is your what we call as the dependent variable. Okay, so this is like 120, 140, 120, 150, 180. Okay, so what we'll do next is we will also add it, so we get summation of y. So if we add these values, we'll get the value of 710. Okay, okay, is everybody following me? So you have added the values of y. Now what you need to do is you need to calculate x. X is your independent variable. Means we want to find out with time what is the change in demand. So over the years, has demand increased or decreased? So what is one very important factor? Year, because we want to see according to time has demand changed. Okay, so that's why now for that purpose what we are going to do is we are taking deviations from x. So here when we write x, we will say that we are taking 2000 as the base year, and from there we are going to calculate deviations. How do we calculate deviations? That means 2000 minus 2001. Okay, so it will be this year value. That means for the first one, I'll just write it so that you understand how we are doing it. So it is like 2001 minus 2000. So what is it? 1 year. Okay, similarly 2002 minus 2000 will be 2. 2003 minus 2000 will be 3. 2004 minus 2000 will be 4. 2005 minus 2000 will be 5. So this is how we have calculated the value of x. After that, we calculate deviations in x, y. Okay. So here, if you see, next we will calculate this. Actually, not. Just 1 second. Let's see if I get a better question. So basically, now if you take over here, you take x square. So x square will be 1, 4, 9, 16, 25. So if we add this value, what is the value we are getting? What is the value you will get? Okay, so sigma x we got as 15. Sigma x square, how much is the value? Please tell me. Actually, yeah, please
It's
tell me.
55.
55. Okay, so similarly, you will find out xy. Find the value of xy. Multiply and find out the value. 120 into 1, that is 120. The next is 140 into 4. Please calculate because I'm just calculating here. That's why.
560.
560. Then you have 120 into 3. No, sorry. XY is 140 into 2. How much is XY? 140 into 2, no? So that is 280. Then 120 into 3.
Okay.
So you've got 120 into,
It's 360.
yeah, into 3. That is 360. Then the next value is 150 into 4.
600.
It is
600.
600. And then you've got 180 into 5.
900.
That is 900. Now, please add this column and tell me the total of sigma xy.
$2,260.
2000, how much?
260.
2260. Okay, so this is the values which we have got. Now there are two line equations which we will use to calculate the values of B1 and B2. So that is very important. I'll just explain that to you. So you've got sigma y is equal to NA plus B sigma x, and sigma xy is equal to A sigma x plus B sigma x square. Okay, so these are the two equations we want to solve to get the values. Now let me just explain what are you wanting to find over here. Okay, so whenever we draw any line, okay, the line is written as y is equal to A plus bx. So y is your dependent variable, because you want to find out, like in this case, we want to find out whether demand is changing with time. So here we have taken demand in this case. X is your independent variable, means time is changing on its own. You are not doing anything to change the year. It will change on its own. So it is called as the independent variable. So here the independent variable is the time or year. Then there are two things, A and B. These are called as parameters. Okay. Now what is A? A is the origin point. So the starting point of the line is A. So the origin of the line is called as A. And what is B? B is the slope of the line. Okay, so this thing is B. Now how does it matter? See, if I've drawn one line like this and another line like this, naturally the rate of change is different. Means this is moving faster, this is moving slower. So that's why we need to calculate these two things, that is A and B. After we calculate A and B, we can get the equation of the line. I'll just put the values and tell you the end values, what is coming. It is just simple simultaneous equations which you need to solve. So I'll just be putting the values and giving you the final values. So sigma y in this case is 710 is equal to how many years? 5a plus sigma x, the value is 15b. And the second equation will be sigma xy, that is 2260 is equal to sigma x, that is 15 a plus sigma x square is 55b. So these are the two equations you've got. So if you multiply this equation by 3, you will get a common factor. You will be able to subtract out A, and you will get the value of B. Okay, so if you multiply this first equation by 3, you can get the common term of 15, which you can subtract out, and then you can find out the value of A and B. I'm not solving it so much because we are a little short of time also. So I'll just try to finish this. So when you solve these two equations, because I think all of you know how to solve your simultaneous equations, so that is not something I need to teach. So you'll get the value of A as equal to 103. You can solve it and cross check whether you're getting these same answers or not. And B, the value of B is coming as 13. So what do you write? You say that the equation of the line, you write y cap, or you can also write it as yc. YC stands for trend line, is equal to 103 plus 13x. Okay, so this is the equation of the line that you have got. Now, what do we do over here is, this is important, that's why I'm coming to this particular area, that you find YC here. How do we find out YC? Like for the first one, what is the value of X? It is 1. So for the year 2001, I can see YC is equal to 103 plus 13 into 1. The value of X. The value of X is what? 1. Okay. So I've substituted the value of X. So what value will come out here? Please tell me. 103 plus 13. So it will come to
160.
116.
160. Okay. So here the first trend value will be 160. Then the second one you calculate. So for 2002, YC will be equal to 103 plus 13 into 2. So how much will it be? 103 plus 26. So what is this value?
129.
129. So this is the second trend value, 129. Third trend value will be like this. You can calculate all your trend values. Okay. So it is 2003. That is YC is equal to 103 plus 13 into 3. What is the value?
39.
How much? 39.
Oh,
So this will come out to be
142.
142. So like this, we will calculate all the trend values. Next one, can you tell me? 2004 will be YC is equal to 103 plus 13 into 4. So it will be 103 plus how much?
52.
62. So it will be
50.
52.
It's 50. Yes.
So it will be 155. Okay. So the next value here that we are getting is 155. And the last value will be 2005. YC is equal to 103 plus 13 into 5. So it will be 103 plus
65.
65. So this will be 168. Okay. So you get 168. Now, very interesting. Suppose I want to get the value for 2006. What will I get? It will be 2006 minus 2000. So it will become YC is equal to 103 plus 13 into 6. So like that, I can calculate any value. So if I want to get the value for 2010, what will be the value? YC is equal to 103 plus 13 into 10. So you can make forecasting or you can make predictions for any number of years based on this particular method. So this is called as the least square method, or it is also called as actually this is called as simultaneous equation method. And like this, through a regression and through time series analysis, we can solve different questions. Is this clear to everyone? Is the method clear to everybody? So this is the last method which we will be dealing with in today's class, and we will continue tomorrow. So tomorrow's class, I will be dealing with production and production, cost, and revenue. So I'll try to complete the different laws of production. I will also talk about different types of cost, the shapes of the cost curves, and maybe little about revenue. Okay, otherwise revenue maybe in the next class, depending on how much time we get. Okay, so that's all for today. I hope you all enjoyed the class, and I hope all the concepts we discussed is clear in class. Okay.
Yes, thanks a lot, ma'am. Have a good evening.
Thank you. Thank you.
Thank you.
Thank you.
Thank you, ma'am. Good night.
Thank you, ma'am.
Thank you.
Thank you, Ma.
Thank you.
Thank you, ma'am.
Thank you.
Thanks, mother.